but hopefully you can see me. I'd normally say do interrupt with questions. If you have a simple mechanism for doing that, feel free to do that, even though this is virtual. I'll try and keep an eye on things popping up on the screen. But first, the ultimate test, can I work technology? All right, can somebody just shout up if you can see a PowerPoint presentation?
We've got lots of yeses coming through in the chat, Laura, so I think you're all good.
All right, I can't see the chat in this form, so if you do get questions coming in, just interrupt me, I don't mind.
Okay, no problem.
Okay, well, I'm Dr. Laura Wilcox. I'm an associate professor in climate science at the University of Reading. And I've been given an interesting brief today to tell you guys a little bit about me and my career and some of the skills that I've used along the way. So a career in climate can mean lots of things to different people. If you ask people to think about what a climate scientist does, you get images of us sitting at blackboards solving complicated equations of the motion of the atmosphere or the ocean. You get a couple of guys from Hollywood blockbusters with unfeasibly good looks and brains and mad Arctic skills. And you also get people that sit in dark rooms on computers running huge simulations on national supercomputers. And you also get the climate activist. So the guy on the screen here is Jim Henson. He was the director of the NASA climate science program for a long time. And is actually most famous for, well, his hat, and also for going to protests and getting arrested well into his 70s. So climate science can give you a lot of different pictures, and most of us do a little bit of all of these things, possibly accepting the chiseled Hollywood good looks. So I started my science career at City of Stoke-on-Trent Sixth Form College. I was there in the old building from 2001 to 2003. I then went to Corpus Christi College in Oxford, where I studied physics for 3 years before moving to Reading, where I did a master's in climate and then a PhD. And then actually I like Reading quite a lot, so I stayed. And I'm currently an associate professor there. So my job at the moment is in aerosol climate interactions. So I run and analyze large computer simulations of how air pollution affects climate. So I'm thinking about how small particulate emissions affect local air quality, but also affect things like global temperature and regional precipitation and Arctic sea ice extent. So let's have a chat a little bit about how I got there. My brief today was to talk about my career journey, employability skills that I've used along my path, and give you guys some advice. So college asked me if I'd do that. I said, yes, sure. And then as soon as I'd replied to the email, I went and Googled what an employability skill is, because I'd never heard of that before. It turns out that those things are just common sense things that you see on lots of job applications that describe your different skill sets. So they're things like your communication, leadership skills, being reliable, the ability to follow instructions and work with other people, and being patient, adaptable, and resilient. And one that I thought was missing from my Google list of skills was not a skill at all, and that was luck. In careers today, you're working with a lot of very qualified people, and a lot of your career direction comes down to being in the right place at the right time and having somebody make a decision in your favor. So you can work hard, but there's always that little bit of luck that's going to spice things up along the way. So back at the turn of the century, when I was at college, I took A-levels in maths, further maths, physics, environmental science, and I also sneaked in a couple of AS levels in Russian electronics, and actually did GCSE Russian at night school as well. So at college, my main decisions were, do I want to do engineering or do I want to do physics at university? By the time I was at college, I knew I wanted to do either science or engineering. I knew I wanted to save the world. I just hadn't quite decided how I was going to do that yet. So engineering, it was an opportunity to redesign engines to give us low impact travel, to send people to Mars, And physics was, I was interested in cosmology and astronomy, and also climate science and earth sciences. So one of the things I did at college to help me make this decision was I went on an engineering course. And this was a week-long residential course where I was able to have a go at different aspects of engineering at the University of Surrey. So I had a go at aeronautical engineering and civil engineering. And at the end of that week, I decided that if that was the best example of engineering, then maybe actually I wanted to do a physics degree. Physics at the time just seemed cooler. So I made my decision. I was going to go be a physicist. And my next decision was, well, where? I had a little Google, as you do. Good universities for physics come up: Warwick, Manchester, York. And then Richard Head, who I think is still kicking around teaching geography, said, well, what about Oxford? I said, well, can't go to Oxford. I haven't been to private school. Turns out actually you can go to Oxford if you haven't been to private school. So that's what I did. I went to Oxford. I took a BA in physics. I was based in Corpus Christi College for that time. And to stop myself being completely boring, I was also the captain of the Corpus Christi swimming team. And in alternate years, I was the captain and the president of the Oxford University Kung Fu Club. So my main decision when I applied to Oxford, once I knew I was going to do physics, was which college. This was back in the days of paper prospectus. So I got a massive book that had pictures of all the colleges. And they all kind of looked the same. Big, old, fancy building, lots of wood panelling on the inside. Some were very close to the physics department, some were very close to the ice cream shop. So naturally, I chose the college that was close to the ice cream shop. And what happens when you apply to college, or what happened then, was that you're given an interview at your first choice college. And then you're randomly allocated a second choice college where you might also have interviews. And that's what happened to me. So I applied to Balliol for the proximity to ice cream, and actually ended up at Corpus Christi College, where I did my second set of interviews. Now, your choice of college is kind of important, but it's not something that you want to hang everything on. The main things your college determine are how pretty your surroundings are going to be for the next 3 years. Corpus is a very pretty, very small college. It only has 200 undergraduates. On the physics course, that meant there were 5 of us taking physics that year. And you can see our team in the bottom left here. So you're going to see a lot of your colleagues in your college through your course. All your tutorials are going to be with these guys. All your lab work is going to be with these guys. All of your teamwork is going to be with these guys, and you're probably going to live with them as well. So this is one of your main skills, is learning how to work as a team and learning your emotional control so you don't kill them when they're late to labs. And when you're an undergraduate, you don't have a lot of decisions to make. You're told where to go for lectures, you're told what work to do and when to hand it in. And if you don't do a very good job, you're told that if you're not in the library from 6 AM to midnight, you're not working hard enough. Which is not necessarily the advice that I'd give you. So you do have some control as an undergraduate. You get to control which optional modules you do. So being interested in space and in climate, I took options in atmospheric science and cosmology. I also did some history of science stuff because it was quite fun at the time. And the Oxford degree obviously is quite hard. So writing some essays for a change actually seemed like a good idea at the time. The main question you're thinking about when you're an undergraduate is, what are you going to do next? And if you're at a big university, you'll have lots of careers fairs. You'll have lots of people come in and try and sell their career and their business. And this seemed like a good idea. A lot of people with Oxford physics degrees go to the city. They make lots of money doing something. But in the end, I decided to run away from Oxford early and do another degree. The Oxford physics degree generally is 4 years long. If you leave after 3 years, you get a BA. And a few years down the line, you actually get a free degree called an MA as well, which is what I did. Now, at the end of my undergraduate degree, I already picked up lots of skills. I've done some projects, I've done some talks, I've got a few communication skills. I've worked as a team in my lab and in my sports. I've had to motivate myself. A lot of my tute work was due on a Sunday afternoon. So you're motivating yourself to work over the weekend as well as getting up for lectures. And you have to be adaptable. Stoke to Oxford is a bit of a culture shock. Certainly when I got there, no one had heard a regional British accent. They thought I was Australian, which was awkward because I've never been to Australia. And it teaches you to be resilient. Going to university after college can be a bit of a shock to the system, especially if you found your A-levels quite easy. You're used to being good at everything without trying that hard. Well, now you're in an environment where everyone's good at everything without trying that hard, and maybe you're not the best anymore. So you've learned to adapt. And 3 years of that was enough for me. So I then went to Reading, where I did an MSc and a PhD in atmosphere, ocean and climate. And it's a very different environment to the University of Oxford. You don't have to wear silly clothes to do your exams or to meet your colleagues or be inducted into the university. Nothing happens in Latin. And it's a more diverse group and a more diverse course. So meteorology is a broad degree, and actually in Reading, we split our meteorology degrees into a few categories. So the ones that I took are more mathematical and more climate focused, and we also have some that are focused more on the practical aspects of meteorology, taking measurements, forecasting and management. And the graduates from these programs go on to a lot of different careers. Some of us stick around, become part of the furniture and never leave. Others go on to be weather forecasters, and a lot go into industry. So some go into finance, some are going to reinsurance, where they're doing weather forecasting for insurers and commodities trading. I learned on the MSc that I loved research. I was super interested in climate, and that was when I decided to stay. So if you stay and do a PhD, this is about the time where you start to be let out into the world to do science. As scientists, we tend to go to a lot of conferences. This is a good way to advertise your work, to meet colleagues and to learn new skills. And I was very lucky. My first conference was all the way to Hawaii, where I got to go to the Mauna Loa Observatory and see the equipment that monitors CO2 levels in the atmosphere. So that was a great first opportunity for me. And when we get to the end of PhDs, I see a lot of students now going, well, I don't know what skills I have. I've spent 3 or 4 years in my bunker doing my research, which has nothing to do with what anybody else is doing. How can I go and get a job now? And actually, PhD students have a massive range of skills. By the end of your PhD, you're fantastic at project management. You spent 3 or 4 years managing a huge research project every day. You've dealt with resource allocation. If you're a climate scientist, you've had to think about your compute allocation. You've had to pay for that. You've had to work out what time you can run your jobs on a computer. If you're more lab-based, you've had to buy samples and equipment. And you've done all that within a budget. If you're lucky, you might also have done some supervision by this point, so you've got your people management skills as well and a bit of teaching. Any science career and any science degree is going to give you critical thinking skills. This is one of our most prized qualities of scientists, is that we can critically assess and evaluate data. And as a PhD student, you're gaining more and more direction of your research as you go through. So you're also learning to think critically about your research direction as well. Where do you want your project focus to be? And how do you want to tailor that project to your future career? You're also able to make quick decisions about the next steps in your project, which is something that's critical for industry. By the end of your PhD, you're going to be a world expert in whatever it was you were studying. Even though sometimes that's a bit hard to get your head around. And a lot of people will work collaboratively and with stakeholders. So my PhD, I worked with the US Federal Aviation Administration. I was trying to work out what the impact of water vapor emissions from aircraft were on climate. So during my PhD, I gave a lot of advice to US government about what the impact of aviation was, and also worked with people like BA to tell them how they could reroute flights to avoid most of the climate change impact. And any big science project these days tends to be very collaborative. You normally want data from somebody else, or you want to have somebody else do some analysis on the data that you've created. And when you write a paper, you tend to do that as part of a team as well. So science PhDs teach you to be collaborative. And if you're going to be collaborative, you need to be good at managing your time. You don't want to be the person that's always letting people down. And this is a really hard skill to learn. You're often multitasking while you're doing this. You're being asked to do 6 different things at once, and you don't want to be late on any of them. And at some point in your career, you're going to get to the stage where something has to go and something has to be late. And then you've got to manage your collaborators as well and manage their expectations. And of course, you only get a PhD if you write a book. So by the time you leave, you've got some writing skills and some skills in public speaking as well.
Laura, you've got a few questions.
Go for it.
So it's a funny one to start with. Did you miss oatcakes when you went to Oxford?
No, my mum posted me them.
Okay, see, problem solved. Next one was, which did you prefer, Reading or Oxford in the long run?
Reading. If I had to do it again, I'd still go to Oxford. But I found it pretty difficult. I was on a course. I was one of 6 women out of 208 undergraduates in my year. There were 5 of us in college. They were all smarter than me, which was weird. And they thought I was Aussie. Reading's a much more relaxed learning environment. It let me do just the things I was interested in. But never underestimate the opportunities you get for having Oxford on your CV. It was difficult, but I think it was worth it. But Reading's much better.
The next one was, were you sponsored through your PhD?
I was, and actually pretty much every PhD in the UK is sponsored by somebody. My PhD was funded by the US Federal Aviation Administration. They paid me a stipend, which was, I think, £7,500 a year. And they also paid my tuition fees to the university. What we do now at Reading, and actually at most UK universities, is we run what we call doctoral training programs. So instead of applying for a PhD individually, you apply to a training program at a university or a group of universities. And most of the PhDs advertised through those programs will come with either funding from the university or one of the research councils. So essentially, you're a low-paid employee who doesn't pay tax when you're a PhD student.
It's quite good, I think.
It's all right, yeah. You don't get a pay rise when you become a research scientist, I tell you that.
Well, that's much better then. That's what they want to hear. We've got, lastly, is that a lot of travel guides on your bookshelf they can see?
Yes, it is. They're a bit dusty at the moment. Yeah, one of the things that we do as research scientists, or we did as research scientists, was a lot of travel, which is kind of awkward if you're a climate scientist, because it means you spend a lot of time on a plane, which is like the worst thing you can possibly do for climate. I like to buy a travel guide for any of the countries I've visited. And I like to balance out my guilt at having flown so much for work by not flying when I go on holiday, which is why there's so many guides to Scotland. I don't know if you can read them.
Okay, I think that's it for now in terms of questions.
All right. So I did my PhD. I really enjoyed my PhD, and I stayed at Reading after my PhD. At first, I was a research scientist, and then I've just been promoted from that position up to a senior research scientist, and now to an associate professor. And essentially, the skills I use and build on every day as a research scientist are the same ones I was using as a PhD student. Just now, there's a bit more pressure. You know, I have to manage myself. I have to win my own funding. And if I make a mistake, everybody knows it's my fault. So I can't blame my supervisors anymore. And now the advice I'm giving is not just to Boeing and British Airways. I'm now advising multiple governments through my work with the Intergovernmental Panel on Climate Change. But essentially, I do a PhD every day. So I've been asked to talk about employability skills. As I said, this was a phrase I'd not heard before. What we tend to think about once we're in a career is, what are the promotion criteria? You know, what do I need to do to get promoted? Those are the skills that I need. You know, those are the attributes I need to get promoted. So these are the examples for promotion criteria in a research criteria, and these things stay the same no matter what level you're at. It's just how much of whatever you've had to have done. So for associate professor, you're asked to do research outputs, and they're looking for 4 publications a year, you know, maybe 10 or 15 in total. For professor, that may look more like 30 or 40, for example. So this is, you know, can you do science? Can you tell people about science? And is it good quality? So there's not much point doing science if you don't tell people about it. We're also assessed on our research leadership, and this can be things like, are we getting invited to give seminars, other places? You know, are people reading our work and interested in it? Do they want to hear what we have to say? And are we putting back into the community? So are we reviewing other people's work and proposals? And then the standard things that you think of as leadership, you know, are we organising meetings? Are we running projects? And obviously a key question when we're thinking about are we running projects is, are we winning money? So as a research scientist, you're employed by a university or a research organisation. But actually, until you're quite senior, if you don't bring in research funding, you don't keep your job. So we have contracts that are tied to our research funding. We're also assessed upon how many PhD students we supervised, how much public engagement we do. So thank you guys for a tick in my public engagement box. And we're also assessed on the impact of our research. So the government is paying for our research, it's paying our salary. It wants to make sure that we're doing something useful. You know, are we getting changes made in policy or practice? Are we changing public understanding of climate? And is our work having a societal benefit? If we do teaching, we're also assessed on the excellence of our teaching. I actually am 100% researcher. I don't do any teaching. But an alternative track through universities is to become a lecturer and to do about 50-50 teaching and research. And the other things we're assessed on are things like academic citizenship. So I call these things just being good at your job. You know, are you giving back to the university? Are you training yourself? Are you keeping your skills current? Are you being invited to give talks? Are you advertising your research? So there's a couple of decisions you have to make as you progress through a career like this. One of the most important ones is who are you going to work with? You know, I've said already that science is a very collaborative thing. You're going to be very dependent on your collaborators. They're going to influence your research direction. They're going to influence the quality of the data you're working with. They're going to influence the quality of your publications. And they're going to form an important part of your network. So a lot of the people you know will also be the people they know. So can you target somebody who you'd like to collaborate with, who can open up new doors to new collaborations in the future? You also need to have a little think about where you want to work. This is based mostly on what the local resources are. And you know, this is something that people put a lot of emphasis on, but I don't think is super important. I actually work part-time at the University of Stockholm as a visiting researcher there. I can work just as well in Stockholm as I can at home, as I can at my office in Reading. And that's been quite handy this year. So I just log onto a supercomputer from my laptop. I can work anywhere in the world. You also need to make decisions about what kind of funding to pursue. So this funding keeps you in a job. And different types of funding put different restrictions on your research. So are you going to apply to some funding just because it's there and it has a high success rate and it's likely you're going to keep your job? Or are you going to target slightly difficult to get funding that is going to allow you to pursue interesting avenues of research? And often you'll be making a balanced decision between those two things. And the decision there will be different at different points in time. You're also going to be making more day-to-day decisions about how you design your experiments. You know, what question do you want to answer? How best do you go about answering that? And how do you design an experiment, in my case, to run on a computer? You're also making decisions about recruitment. You bring in research funding for a group, not just yourself. So who do you want to come on board? You know, what skills are they going to bring to your group? And one of the big questions as an academic is, you know, should I say yes to that? Lots of people want you to do things. We have very vague job descriptions. And we have to do a lot of juggling of our time. It's very easy to say yes to everything. That tends to end badly. So you have to think about, what's an opportunity for me? What do I get out of this thing? And in the back of your mind, you're always going to bring that to your promotion criteria and your employability skills. And I said at the beginning that luck is really important. So a lot of success in an academic career is being in the right place at the right time. Have you met the head of NASA? Have you met this really important person? If they know you, they're more likely to want to work with you. They're more likely to want to send people to visit you, and that really grows your network. And if you have a good network, you're better placed to do high impact science. You're also, again, at the mercy of committees making decisions about funding. So as with university, in a research career, you're in an environment where everybody is good. Pretty much everybody applying for that funding that you're applying for would do a good job of the science with that. And 4 or 5 people are going to sit around a table and make a decision about whether they give it to you or they give it to them. And a lot of the time, that's just going to come down to whether they're interested in the thing that you're interested in too, whether they understand what's in your proposal so they can understand why your research is better than what the other guy is proposing. So a lot of that is just luck. One committee might give you the money and the other one might not. And it doesn't matter what you've done. So all you can do is try your best and cross your fingers. And if you're a climate scientist, the weather is also important. If you're looking to advertise your research and you've just spent 12 months doing some research on flooding, and then there's a massive flood in the UK, you're going to end up all over the news. Your work is going to end up all over the news. And that can be very good for your career as well. And obviously you have no control over that, but you're in full control of how you engage with that. So that's an example of when it's good to say yes. Talk to the press officer, go, yes, I will go on Sky News, I will go on Radio 4. And that can help you a lot too. So one of the things I would say is that you can be successful without succeeding at everything. And we live in a world now where we're very driven by social media and we're surrounded by these perfect images of people's lives. And I think you're going to see a lot of these talks this week, and it's going to be a lot of people who've got great jobs and great careers coming along going, look how great my job is, you want to do this. And behind all those successes, there's normally some failures as well. So I'm a good few years out of my PhD now. I have 42 publications, but about 15 of those required major revisions. Some of them took over 2 years to get published, and 5 of them were rejected outright. So there should be 47 on that list, in my opinion. And those rejections included my first ever submitted paper as a PhD student. I sent it to quite a high-profile journal. I tried to put too much stuff in the paper and they weren't having any of it. So it came back and I had to send it somewhere else. So that was a good introduction to an academic career. And I learned a lot from that. Another thing that's important to us is research funding. So I have managed and won £3.6 million of research funding in my career to date, which sounds great. But behind that is the £9 million I didn't win. So this is just a case of keeping trying until you're lucky. And there's many examples where success can come from failure in a career like mine. I had in my PhD a massive computer failure. The computer I was using to run my PhD simulations at Reading failed, was turned off and never came back on again. So I had to find a new way of doing my simulations. And actually I ended up with something better. It would have taken me over a year to run what I need to run at Reading, and I found a way to run them in parallel across lots of supercomputers at the same time. And actually they were done in a few months. And if that equipment hadn't failed in the first place, I'd have just kept on slugging on. Your unsuccessful grant applications are never time wasted. You build on them, you get feedback from them a lot of the time, so you learn why you failed. And this can help you to think about something different. Do you need to present something different? Do you need to approach a problem in a different way? And you can also have null results as part of research careers. So if something turns out to not be important, that's an important result, but perhaps not great for your career. Is it time to think about something else? And that's something that I did after my PhD. Aviation is very, very important for climate change. Water vapour emissions from aviation are a really, really tiny component of that. And actually, I was the first person to look at that for 10 years. I did everything through the PhD that should have made the impact as large as possible, and it still came back being smaller than the best estimate. So I conclusively proved that it didn't matter. And that's when I decided that I was going to do something more with atmospheric dynamics, and moved into ozone and air quality and the impacts on atmospheric dynamics. And something else that's important is that your career path doesn't have to look like everyone else's. My path has been pretty traditional. I went to uni, I did a bunch of degrees, and I've stayed at uni and I'm academic. You can actually have a career in climate and research science that doesn't look like me sitting in an office for 10 years. So I'm just going to quickly go through another example. I'm going to perturb our initial conditions like we do with our climate model, and take a younger, cooler version of myself who came through the City of Stoke-on-Trent Sixth Form College a few years after me, and is currently a postdoctoral research scientist in a national centre. So a very similar centre to where I work, but a few years behind. So this is my little sister. She went to college in Stoke. She then went to University of Portsmouth and Southampton, and then she's done a load of cool stuff in sunny places. She took A-levels in chemistry, biology, and environmental science. So she's a proper scientist. She stands in a lab. She wears a lab coat. So after she did marine environmental science at University of Portsmouth, she went to Southampton. She did a couple of research degrees there that involved shooting bits of coral with a laser, and dissolving them in all kinds of acid. And she did this to work out how temperature in the sea and how pH in the sea had changed in the regions those corals were living. As part of that PhD, she also went on Arctic field campaigns to measure pH in the ocean up around the poles. And she's been on national deployments as well to repair our national research infrastructure. So one of the things we're involved with in the UK is called the Rapid Array. And this is a series of sensors strung across the Atlantic that measure the overturning circulation in the Atlantic. So she went out on the Discovery and did some repairs on that and used that as an opportunity to take some samples for our own research as well. So a bit different to sitting behind a computer and only being let out a few times a year. And during her PhD, she realised that she was interested in being outside. She liked the practical stuff. She loved scuba diving. She then went to Utila, became a scuba instructor, and did all kinds of horrifying scuba qualifications, so cave diving and night diving and emergency treatment. She lived in a little hut. She drove this little boat around, and she finished writing up her thesis in a hammock in Belize, which is, very different to me sitting in my flat in Reading. And she really enjoyed that experience there. And from there, she decided that she really enjoyed the scuba diving, but she wanted a bit more science. So she moved to the Philippines and became a lead researcher for Marine Conservation Philippines, where she actually set up a coral monitoring program and a research program, as well as a dive center. So this is her house in the Philippines, and her truck and her pet toilet spider. So this involved everything from planning the layout of the new site, to sinking the bits of concrete into the bottom of the ocean where they were going to grow new coral to monitor, to repairing all the equipment. She was at a very remote place in the Philippines, and they were very dependent on themselves for everything. So she had to learn to be an engineer, which was pretty tricky for our chemist. Since then, she's come back. She now works at the National Oceanography Centre in Southampton, where she does proper science in a lab with a lab coat. She's done some work on boron isotopes for climate change, so proper clean lab, absolutely no dust, got to wear lots of PPE. But she still gets out sometimes. She's still involved in coral research, so she's been recently to Barbados, where they've taken coral samples and set up a coral monitoring program there. And she also does some outreach, so a bit of coral monitoring and sea surface temperature monitoring in Fiji, along with capacity building in the local communities. And whenever they do these things, they always do a bit of a beach cleanup as well. So the pile of shoes here is apparently 5 minutes worth of beach cleaning. So that's a very different research career to mine. Starts from a similar place and ends in a similar place, but with very different background qualifications. So that's my time. I'm going to stop there, and if you guys don't mind, I'm going to turn the slides off so I can see you guys and we can have a chat.
So we've got a few questions coming through now, Laura.
Okay.
How long was your thesis? How long was your book that you had to write for your PhD? We've got a few questions about that.
So this is my PhD thesis. It is 258 pages.
Oh, that's nice and short then. We've also got, do you speak any Swedish with being based in Stockholm?
Ja, jag talar lite svenska.
So yes, then.
Mostly people in Sweden speak amazing English, and it's really difficult to learn, actually. As soon as they hear the British accent, they switch to English. So you've got to really nail the pronunciation.
What beach was that with all the shoes on that your sister did beach cleanup on?
That one was Tuvalu, I think, but don't quote me. she does it in lots of places.
Have you got any advice for getting into a really good university, because you got into Oxford?
Well, it involves a bit of hard work now. You want to do the best you can on your exams. Obviously, the main entry criteria are going to be your A-level results. If you're going somewhere that has interviews like Oxford or Durham, do some reading. Some of the best advice I was given at college was to read New Scientist. Get an idea of what's at the forefront of science now, so that when you're asked about it in an interview, you can talk about it. And have a think about what you want to do with your degree. Those are some of the questions that I was getting in interviews. Why do you want to do physics? What do you want to do next?
How long was your journey to where you are now in comparison to your sisters?
So obviously I'm 4 years older, so I've cheated. I've had a head start. I went through the degrees quicker. So I did a BA, an MSc, and a PhD, where she did a 4-year undergraduate course, then a 1-year MRes, then a PhD. But then time-wise, otherwise, it's pretty much the same. So I had a bit more luck with funding applications recently than she has. So I'm probably inching ahead. But it is not that different. Okay. We'll go straight into research after a PhD.
And then lastly, what was the title of your thesis?
I'm going to have to look that up. It's a good job I got it on my shelf, isn't it? The title of my thesis was The Tropopause and the Climate Impact of Water Vapour Emissions from Aircraft.
Oh,
there you
go. Has anybody got any more questions for Dr. Wilcox while we're here?
Water does make sky go hot, you're right. I wish everybody understood that. Oh, and you don't write your thesis in one go. So I've been asked how long it takes me to write my thesis. I spent 3 years and 3 months in total on my PhD. I probably started writing my thesis halfway through my 2nd year, and you write it in chunks. So the introduction chapter I wrote from start to finish in 2 weeks, but the rest of it was a super long progress. Did I just see how do I manage my time flash up? Badly.
Yes, you
badly.
did.
I don't know a good answer to that. I've tried a few things. It's tricky. Once you get a few years into a research career, you tend to work on several projects at once. Everybody wants you to work on their project first. So you have to learn how to set boundaries. And you also need to balance producing your research outputs with winning funding. So it's a tricky one. Answers on a postcard, please. I'm always trying to learn.
We've got what revision techniques did you use for A levels?
I mostly hung around with boys instead of doing revision. I was a big fan of writing stuff out. I went through my lecture notes and condensed those into shorter revision notes that I then memorized. That works really, really well for A levels and is a terrible approach to a degree. If all you're being expected to do is regurgitate information, memorizing stuff that way is super helpful. Once you get into a physics degree, you're expected to think. So anything you can do to teach yourself to think early is going to really help you when you get to university. So think about slightly different problems, applying the same techniques to what you need for exams and things like that.
Definitely. And then lastly, I think, is which emission is more damaging, CO2 or water?
Well, it depends what you mean by that question. They're both very powerful greenhouse gases. If that's a question about our emissions, then CO2 obviously is way more damaging of the things that we emit. That's true for aviation. That's true for human emissions in general. There's loads of water vapor in the atmosphere, so a little bit that we emit doesn't make that much difference. But CO2 really adds up.
Oh, and I think you've had one last one. Is water more volatile?
That sounds like a chemistry question. Can't answer that.
I think that's it. Any final questions?
I'm not doing the Russian demonstration. Sorry, guys.
Yeah,
it's a long time since I did that.
Anyway.
Oh, is water easy to get rid of? CO2 is probably easy to get rid of. We have carbon capture and storage. Water's tricky because if you pull it out of the atmosphere, you just put it in the sea and then it evaporates again. And it's back in the atmosphere before you know it.
We've just had a suggestion of just put a paper towel on it.
That doesn't work so well for the CO2 though, does it?
No, and we have to have a very large paper towel.
But I mean, that's kind of where we are with climate science. We have a lot of discussion about geoengineering and should we put giant mirrors in space and should we pump reflecting particles into the stratosphere? And those are real serious discussions. We're in a real serious position now with climate change where we need to do stuff 20 years ago. So yeah, we're talking about crazy stuff now.
We're having some crazy suggestions in the chat, so future climate scientists here, I think.
Yeah.
So and thank you very much, Dr. Wilcox. It's been I've learned so much from you. And for these guys, it's really important to have somebody who's an alumni as well, who's been in their shoes and who has ended up in kind of a career that they really value and that they're happy in, and kind of to find out the journey about getting there. You've got a couple of thank yous coming through in the chat as well.
Oh, you're welcome, guys. Go to a physics degree. It's the best. That chemistry rubbish.
Some of these do physics as well, which makes this kind of a better talk for these lot.
Yeah. Keep doing physics. There aren't many of you left. If you get bored of science, you can make a load of money being a physicist.
Well, there you go, guys. Tip of the day. Make lots of money being a physicist. And there you go. That's it. There's a physics gang now.
Right.
Thank you very much.
Being a physicist, so you have to do the right kind of physics to make the money.
A few regretting their A-level choices now. Damn, it's too late to change my A-levels.
It's never too late to change your A-levels. You can always do more.
And then we've got a lot of physics is hard, though.
Yeah, but it's interesting because it's hard.
Yeah, it does make for a longer career journey, I think. So if you find it more difficult, there's always something more interesting to look into as part of the subject.
Yeah, that's true. And you know, the biggest kept secret about science careers is that once you've done your degree, you don't need to do hard stuff anymore. You know, I did real crazy hard stuff in my undergraduate physics degree, and you know, we do some super difficult fluid dynamics in our master's course. And now my day to day, I find the mean and standard deviation of things and plot it. So that's nice. Most of what I learned in my degree, I never used since I left, and I can't see me ever using ever again.
So there you go, guys. Hard stuff done by the end of the degree, unless you actually want to do the hard stuff every day.
Yeah, you just got to suck it up for 3 years, do some hard stuff, and then you're done. You're free.
Okay, thank you very much. It's been an absolute pleasure, and I think these guys have learned a lot, and I've learned a lot from it as well. And we've got the recording of the meeting that I'll post on Classroom, so if these guys have missed anything or anything to do with kind of the computers going wrong or whatever, they can have another look at it as well. Thank you very much.
You're welcome, and good luck with your A-levels, guys. You've got a bit of a challenging year this year.
I'm sure they'll all be fine.
I'm sure you'll be fine. You're at a great college.
Thank you. Cheers.